Atola TaskForce 2 excels in retrieving the maximum amount of data, even from bad drives, without causing further damage. To pinpoint any issues with a drive, we recommend always diagnosing first. Here's a diagnostics report of a damaged drive. We can tell that by its yellow or red color on the home screen, as well as by the color of the results field at the beginning of the diagnostics report. Good and bad drives require different approaches to image them. With bad drives, we want to retrieve as much data as possible, prevent further drive damage, ensure image data integrity, and, last but not least, optimize imaging time. Knowing that, let's image a damaged drive. Click Image and select your source and target devices. If the drive has any major or minor issues, TaskForce recommends using the special preset for imaging damaged devices. The preset for bad drives is based on our decades-long experience in the data recovery market to overcome most types of damage to the drives. The damaged preset has two main differences from the default one. First, instead of one-pass linear reading, it uses the multi-pass imaging algorithm. This helps to handle the damaged media as gently as possible and retrieve the maximum amount of data at optimal speed. Second, to ensure image data integrity, the damaged preset uses segmented hashes instead of linear. More on that later. Now, let's go back to our bad drive and have a thorough look at the imaging settings to understand how they help TaskForce handle the damaged media. On the Passes tab of the imaging settings, you can see the 5 passes instead of 1. Each pass has different parameters. This multi-pass imaging functionality helps balance out thorough data extraction with careful treatment of damaged media. Here's how it works. This is the space of the drive that you're imaging, and TaskForce reads data sequentially from the first sector to the last one. Once TaskForce encounters the block that contains a bad sector, it performs an automatic jump by 1 million sectors as defined by the settings of the first imaging pass. Then it continues to image the sectors after the skipped area. So, why do we choose to perform the jump after an error? Because, based on our experience in data recovery, errors often come in groups, and you will encounter more errors in the subsequent sectors in many cases. That's why we choose to skip the potentially bad area and continue imaging the good areas of the drive first, for a more efficient imaging process and more gentle treatment of the drive. Once the first pass is completed, TaskForce returns to the problematic area of the drive and spends a little more time, as defined in timeout settings, to read data in this area. Should it encounter another bad sector in this area, it will make a smaller jump by 20,000 sectors. On each subsequent pass, TaskForce will be allocating more time to read a bad sector and making smaller jumps to narrow down the bad areas of the drive and efficiently read data from the good ones. At the end of the last pass, you will end up with 90% or more of the data from the drive. Very often it's 95, sometimes 99%. Now, we can better understand key settings each pass has. The jump on error defines the number of sectors the imaging engine will skip on this pass upon encountering an error. The timeout setting defines the maximum time TaskForce will spend trying to read the data within a sector. The max read block size setting. The bigger it is, the faster the data is read, but smaller blocks allow a more thorough data retrieval process. As you can see here, the multi-pass algorithm uses large blocks with short timeouts on the first few passes, scheduling reads inside slow areas for later. And then it uses the smallest block size on the last pass, when fewer sectors are left to be read. We suggest that you use the damaged preset for bad drives, unless a particular drive requires a specific imaging approach. In case you need to adjust the settings, click on a pass. To narrow down the bad area of the drive faster, we can select the reverse direction option, and TaskForce will read all the good sectors in the opposite direction, up until it hits a bad sector. Reverse direction is inactive now, because we have the hash source during imaging option selected. Disable Read Look Ahead option prevents the drive from caching the sectors beyond those addressed by the imager. You can adjust the pattern with which the unreadable sectors will be filled on the target device. The passes with adjusted settings are marked yellow.